So we're looking at another chi-square goodness of fit, but this isn't a probability distribution, so I'm just giving you another example. This is one where maybe we're doing a test on some data and seeing if it fits in with historic or planned levels. So we can see that we've got a new IB subject, and we think the grade should be 5% of the people should get a 1, 10% should get 2, and so this is what I expect. But I've done a test, and here are the actual grades, and I want to see if it's got a goodness of fit. So first thing is, let's set out the hypothesis that the grades fit the boundaries set out, always that it actually does fit. The grades do not fit the boundaries as the alternate. Now I've got a 5% level of significance, and my degrees of freedom, I have 7 categories, so 7 take away 1, 6. I then set out my 2 tables here with my observed, which is just a copy of this one, and my expected, which were given here. So once I've done that, I'm going to go ahead and grab a calculator. And from the calculator, I'm going to go into the statistics mode, and I'm going to enter the data into the first 2 tables. So I've got observed, expected. I'm going to just do the test chi goodness of fit, list 1 observed, so those are in the correct places. Degrees of freedom is 6. I'm going to go ahead, and I've got p equal to 0.115, and also I've got my chi-squared. Now I'm not going to draw any diagrams, but I do encourage you to draw the diagrams. So my chi-squared, which they may require, is 10.2. It's always good to state it. That's my test statistic. My p is equal to 0.115. Now I'm going to make my conclusion. Now p is greater than my alpha. So that means I'm going to accept HO. So if you were drawing a diagram, it would be within that white zone. So that means that these grades do fit very well within the grades they suggest.